I scored a 524 on the MCAT. Let me show you how I answer questions.
Question 12. Which of the following describes the orbital geometry of an sp3 hybridized atom? And we have A, linear, B, trigonal planar, C, tetrahedral, and D, octahedral. Well, something that's sp3 hybridized, you have to remember, is going to be usually like a carbon that's bound to four things via single bonds. So it has four bonding domains, okay, or four electron domains, and all of them are bonding or single bonds, okay? So this is going to be sp3 hybridized. And as it turns out, the bond angles between these bonds are all going to be the same all around, and it's going to be approximately 109.5 degrees. Not quite, but almost 109.5 degrees, okay? And the geometry of such a molecule, or such a carbon or an atom that's sp3 hybridized is tetrahedral, okay? So C is going to be the right answer. Now, if it were linear, it would look something like, for instance, carbon dioxide, where you have two bonding domains here, but they're double bonds. And so the bond angle is 180 degrees, okay? If it were trigonal planar, it would look something like this, like, for example, a carbonyl group, okay? And this is actually going to be planar with 120 degree bond angles, okay? And this would actually be an sp2 hybridized carbon. And by the way, here, this would have to be an sp hybridized carbon, all right? Now, octahedral would be something like SF6, where it actually has 6 things bonded to the central sulfur atom, looking like this. And then we're going to have fluorines going into space. And so here, between all of the individual bonds, the angles are actually 90 degrees, with the exception of these two fluorines, which is 180 degrees. So that would be octahedral, all right? And here, you would actually have electrons in like d orbitals, all right? But generally, if you ever have an sp3 hybridized atom, it's going to be tetrahedral. If it's sp2, it's going to be trigonal planar. And if it's sp, it's linear. So C is the right answer.